In this video, we're going to be taking a look at flow control valves. When we're done with this video, we're going to understand how the flow control works, how the internal components are set up, and how we can use flow control valves to manipulate our circuits. Here is the symbol for the flow control valve. The flow control valve has multiple components, and we're going to take a look at a couple of them now. Starting with the orifice, these concave lines represent the orifice of the flow control valve. This is what controls or meters the flow through the valve to the actuator. Next, we have this diagonal line with the arrow. That represents an adjustable. So it makes it to where this orifice is adjustable. Anytime that you have a diagonal line with an arrow on that, it means that that particular object can be adjusted. Next, we have the check valve. So here's our check valve. Our check valve is composed of two components, the ball itself and then the seat. So as pressure builds on this side of the ball, it forces the ball into the seat and doesn't allow for the flow to pass that ball. Now, with our flow, it's going to travel this way. It hits the ball. It can't go past that, so it forces it through the orifice. Now, if we reverse the flow now travels back this way. It travels down through here. It hits that ball, it pushes the ball off of the seat and allows for the fluid to flow around the ball and free flow back to the other direction. It doesn't require the fluid to flow through the orifice because this path has less resistance than the path of the orifice. Here we have a pneumatic circuit that is utilizing two flow control valves. These flow control valves are metering inflow and outflow to the actuator. So when we shift our directional control valve, the cylinder retracts. When we shift it again, the cylinder extends, which fluid gets shoved through here, which this meters the flow. When we return it, the flow is allowed to free flow through the ball check here while it is being metered back. In this demonstration, we're going to illustrate meter outflow to control a motor. The way that we have this one set up is we're going to have our supply flow come through here, and we are going to meter our outflow through this flow control valve right here. With my air control turned on, we are applying full pressure, so full manifold pressure. Our manifold pressure is set at about 22 psi right now. And we can see that our motor is spinning, albeit very slow. It's because we are blocking the outflow, or we're metering the outflow rather, with a flow control valve. So we can take this flow control valve and we can turn it up, and actually we're reducing the amount of restriction. And this speeds up, and then we're going to slow it back down again, and then we can slow down the motor. So one of the advantages of having meter outflow is that it allows for your actuator to maintain full pressure all the time, and we're just basically blocking the exhaust or the return side to control our speed. So just to show what happens if we lose the line on this, we can take this line loose and we're going to get full speed on our motor again. So our motor goes into full speed again. So there's our full speed with our flow control valve.